Hello everyone. In Geometry for CAT series, we are learning about quadrilaterals. And today, let's discuss about parallelograms. So a parallelogram is a quadrilateral where one pair of opposite sides are equal as well as parallel to each other. Now, only this property makes it a parallelogram. Otherwise, we can also say that opposite pair of sides are parallel and equal to each other. So, parallelogram A, B, C, and D. In this case, AD will be equal to BC and parallel. Also, AB will be equal to CD and parallel. Okay. So, in that case, what we can say, other properties regarding parallelogram, that if we need to find the area, let's say the angle between two sides is theta. If this side length is A, this will be B. If this is A, this will also be B. So what we can say, the area of this parallelogram will be equal to A into B sine theta, which is AB sine theta. Okay, very similar to the area we found of a triangle when two sides and the angle between them is given half AB sine theta. This is same thing. Now, apart from that, what will be the perimeter? So, perimeter will be equal to 2 times A plus B. Now, in case of parallelogram, if we talk about the diagonals, so what do we know? In case of diagonals bisect each other. So these two are equal. Let's say this point is O. OB will be equal to OD, and other diagonal is also like OA is equal to OC. So in any parallelogram, the diagonals bisect each other. All right. So these are the basic properties of parallelogram. Now in parallelogram, there are 3 more types of quadrilaterals. Another type of quadrilateral is rectangle. In rectangle, now remember, in parallelogram, if one of the angle is theta, then other angle must be 180 degree minus theta. And then opposite angle will be same, theta, and this will be 180 degree minus theta. So we can also say that in a parallelogram, the sum of two adjacent angles is always equal to 180 degree, or they are supplementary. Now in case of rectangle, what we can say, that PQRS is a parallelogram. It will be a rectangle if one of the angle is equal to, one of the interior angle is equal to 90 degree. If one is 90 degree, then opposite angles are equal, so this will also be 90 degree. And sum of adjacent angles is 180 degree, so this will also be 90 degree. Hence, all the angles are 90 degree. Now, in case of rectangle, what is different from parallelogram, that the area will be equal to AB sine theta. Theta is equal to 90 degrees. So we can simply say this is AB. If this side length is A, this side length is B, this will be A into B. Perimeter will remain the same throughout all the parallelograms. Apart from that, we can also say that in rectangle, the diagonals are equal to each other, like QS is equal to PR. Now remember, all the properties that we have discussed in parallelogram that will work in rectangle, these are the extra properties that we are discussing. Like diagonals are not necessarily equal in all the parallelograms, but in case of rectangle, the diagonals will be equal to each other. Of course, they will be bisecting each other. Now, if we talk about square is a parallelogram where all the side lengths are equal. All the adjacent sides are equal to each other. Now, this brings lots of new concepts regarding a parallelogram. In square, both the diagonals are bisecting each other. They are equal and they are also perpendicular to each other. Okay. Apart from that, we can also find the area. Area of square will be equal to a square because side length a and a. Perimeter will be equal to, perimeter P will be equal to 4 times a. Now in case of other things in any parallelogram or particularly in rectangle, if you want to find the length of the diagonal PR, which will be equal to QS, let's say this is equal to D, this will be equal to square root of a square plus b square. We can use the Pythagoras theorem. This will be the length of both the diagonals. In this case, the length of diagonal D will be equal to a root 2, where a is the side length. Now, other things that we can discuss is about rhombus. Rhombus is also a parallelogram where all the side lengths are equal. So A, B, C, D is a rhombus, is a parallelogram whose all side lengths are equal, but the interior angles are not necessarily 90 degree. So in that case, one property that we know is true, that the diagonals are perpendicular to each other. That means AC is perpendicular to BC. What else do we know? That they bisect each other. The diagonals are bisecting each other, right? Apart from that, we can also say that area of a rhombus is equal to half D1 into D2, where D1 and D2 are nothing but the diagonals of a particular rhombus. All right. So as I said, in case of parallelograms, there are 4 different kind of parallelograms. Simple parallelograms, then comes rectangle, then comes square, and then comes rhombus. Every square is a rectangle, but every rectangle is not necessarily a square. Similarly, every square is a rhombus, but every rhombus is not a square. All right. So let's try to solve the questions on the basis of this. It says the sum of the 3 sides of a rectangle is 80 units. What is the maximum possible area of the rectangle? So we have a rectangle, something like this, and this side length is A, this side length is B. What we can say, that sum of 3 sides, so 2A plus B is given, 2A plus B is equal to 80. What will be the area? So area will be equal to A into B, right? And this is 80 given. How do we find it? So one very important concept is there, which is AM is always greater than equal to GM. Arithmetic mean of 2 values is always greater than equal to geometric mean if those 2 values are positive numbers. So we can say that 2A plus B divided by 2 is greater than equal to square root of 2A into B. So from there, this is 80, 80 by 2 is 40, is always greater than equal to square root of 2AB. Now if we take square on the both sides, we can say 2AB must be less than equal to 1600, or we can say that AB must be less than 800. And what is AB? AB is nothing but the area we are looking for. So the maximum area of this rectangle must be option B, which is 800 square units. Now, next question, it's a really good question based on a square. A square is inscribed inside another square as shown in the figure. Each vertex of the inner square divides the side of the outer square in the ratio of A to B. where a greater than b. The area of the inside square is 9 by 11th of the bigger square, then a by b is, what do we know, is area of smaller square, right? So area, if this value is k, let's say if this value is k and this is perpendicular, what we can say, k will be equal to square root of a square plus b square. The length of the bigger square is nothing but a plus b whole square. The side length will be a plus b whole square, and respectively the side length of smaller square will be k. So this divided by k square is equal to 9 by 11, right? This is equal to 9 upon 11. Or we can say, if I break this, I can write a square plus b square plus 2ab divided by, what is k square? Can we say using Pythagoras theorem? K square is nothing but a square plus b square. So a square plus b square is equal to 11 upon 9, right? The ratio is 11 upon 9. Now we can say that if I cross multiply this, what do we get? We get 9a square plus 9b square plus 18ab is equal to 11a square plus 11b square. So from there, if I take this right side, we get 2a square plus 2b square minus 18ab is equal to 0. Now, what do we want? We want a by b. So let's divide this whole expression by b square. We get 2 a square upon b square, which makes it a by b whole square, plus this will become 2 minus this will become 18 times a upon b is equal to 0. Now divide this whole value by 2. So what do we get? And take a by b is equal to x. So divide this 2 and put a by b is equal to x. This will become x square minus 9x plus 2 is equal to plus 1 is equal to 0. So from there we can say x will be equal to, using finding the root of quadratic equations, this will be 9 plus minus square root of b square minus 4ac. 81 minus 4 is 77 upon 2. Now x is nothing but a by b. Now it's given that a is greater than b. If a is greater than b, a by b must be greater than 1 here. So think about this. If I take 9 minus square root of 77, that value will become less than 1. So that's why we don't need to take the negative value. It will be 9 plus square root of 77 upon 2. And that is the value of a by b. So our answer is option A, 9 plus square root of 77 upon 2. Next question. ABCD is a square where EF and N are the midpoints of the side AB, DC and BC respectively. What is the ratio of area of triangle DEM to the quadrilateral EB and M? So can we say, if I take a square something like this, okay, and I break it like this, and if I join this, if area of the whole square, if I imagine area of the whole square is 16, this will be 8 and this will be 8, but these two will be equal, so this will become 4 and this will also become 4. And F is the midpoint, right? F is the midpoint, E is also the midpoint. These two lines will be parallel. So in that case, we can say triangle DMF will be similar to triangle DNC, where side ratio will be 1:2. If side ratio is 1:2, the area will become 1:4. Area of triangle DMF to the area of triangle DNC will become 1:4. In that case, total is 4. Can we say, if I take this area as x, this must be 3x. If this whole is 4x, this also must be 4x. and this half square must be double of this, which is 8x, 4x, x, 5x. So this must become 3x. And the rectangle EFCB, area of this will also be 8x. We already have 3x. This must be 5x. So what do we want? We want area of triangle DEM to the quadrilateral area of quadrilateral EBNM. So that will give us 3x by 5x, which is nothing but 3 upon 5. And that's our answer, option C. Really good question based on similarity and square. Next question, it says find the area of the colored region in the given figure where ABCD is a square. So let's say that this part is, area of this triangle is A, area of this triangle is B, area of this triangle is C, and area of this triangle is D. Now can we say that if this point is M and this point is N, can we say the area of triangle AMD will be nothing but half of the square, because base AD, height will become DC. So area of triangle AMD will be half of AD into CD, which is height, and area of square is AD into CD. So area of triangle AMD will be half of it. Now let's say this shaded region area is nothing but X. Can we say area of triangle AMD means A plus C plus X will be equal to area of rest of the square, which will be equal to 15 plus D plus 40 plus C plus B. And similarly, we can say area of D and C will be B plus D plus X. And this will be equal to the rest of the area apart from anything. So that will be 10 plus C plus 40 plus D plus 15 plus A, right? 10 C 40 15 A, 10 C 40, acha, not D. D is part of already, D is part of the given triangle. So this will be 15 plus A. Now if I add these two, what do we get? If you add these two, so this will become 2x plus A plus B plus C plus D, which will be equal to, now we have 10 40, in that case 15 40 10. I missed this here, it should be C plus 10 here. So this will be 10. Okay, so in that case this sum will be twice of 15 plus 10 plus 40 plus DCCA, right? DC, 1 second. In the first case, it should have been DC 440 10B, DC 15D 40 10B. Okay, instead of C, it will be B. Okay, so we get A plus B plus C plus D. This is what we get, right? AC, BD. Now this will be cancelled out, as you can see, or we get X is equal to 15 plus 10 plus 40. So 50 plus 15, which is 65 unit square. So in this case, you can directly remember that, forget everything. Whenever this area is asked, you can simply add these values. Okay, add these values, you will get your answer. Like Simple and easy. Now, next question says in a quadrilateral ABCD, diagonal AC and BD intersect each other at E. So we need to make a quadrilateral first, something like this, and join the diagonals like this. So A, B, C and D. Now it says diagonals AC and BD intersect each other at E. Let's say this is E. If the area of the triangle ABC to the area of triangle ADC is 3:5, what is B is to ED? Now let's say area of this triangle is A1, area of this triangle is A2, this triangle is A3 and this triangle is A4. What we can say that B is to ED. In that case, can we say that A1 upon A2 will be equal to B is to ED, so A3 upon A4. This will also be equal to A3 upon A4. Let's say this is equal to K, right? Now, in ratio proportion, there is a very interesting concept that if A by B is equal to C by D is equal to E by F and so on is equal to K, then we can say that A plus C plus E plus in denominator B plus D plus F and so on is also equal to K. So using that, can we say that A1 plus A3 will be equal to A2 plus A4, right? And see, this value A1 upon A2 is nothing but BE upon EC, right? Because in any triangle, the ratio of the base is same as their corresponding area of the triangles. So A1 plus A3, A2 plus A4 is nothing but area of triangle ABC divided by area of triangle ADC, and that is given. What is that? This is given as 3 by 5. So this should be K, right? If this is K, adding the numerators, adding the denominators, we can say this will also be equal to K. So can we say that K is nothing but 3 by 5? And our answer is option C. Okay. So with this, we are done with second session on quadrilateral in geometry for CAT series. Thank you.